Hello everyone, in today's math challenge, we will take a look at a professor's age question, which should not be too hard. A professor is in his 70s. He said, I am 27 years older than my son. This year, if you swap the unit and the tenths of my age, it will be equal to my son's age. So here is the question. How old is the professor in this year? This question should be fairly straightforward, and you can pause this video and spend some time to work on it, and then we come back for the answer. Okay, let's have a look at the answer together. Firstly, it will be fairly quick, even you use the trend arrow to solve it, because the professor is in his 70s, so that means his age must be 70 something. You can just try 71, 72, 73, etc. It won't take very long time, you will find the correct answer. However, I still recommend you to use the standard algebra method, and you will see the benefits of it later on. In this case, we can set the professor age as 10x plus y, and because if you swap the tenths and units of the professor's age, it will be equal to his son's age. So that means his son's age can be set as 10y plus x. And since the professor is in his 70s, here x must be equal to 7. This will just make this question much simpler. Okay, so the professor's age is 70 plus y, and his son's age is 10y plus 7. And because the professor is 27 years older than his son, and we can build up this equation, 70 plus y is equal to 10y plus 7 plus 27, and it is quite easy to solve this equation where y is equal to 4. So that means in this year, the professor is 74 years old and his son is 47 years old. However, I do have an extended question to ask. For example, if we do not know that professor is in his 70s, so there are many possibilities. So how can we solve this question? So you will find by using try and arrow, it will be much harder. And let's just try to use the standard algebra method and see how easy it will be. So you can pause this video here again and spend some time, and we come back for the answer. Okay, so we can still use the same setting. The professor's age is 10x plus y, and his son's age is 10y plus x. And we can still use the same equation. Okay, the professor's age is equal to his son's age plus 27. And for the first step, we can move 10y plus x to the left side, and 10y will become minus 10y, and x will become minus x. So 10x minus 10y plus y minus x is equal to 27. And we can combine this 10x and 10y by doing a little factorization. So here, 10 times in the brackets x minus y plus in the brackets y minus x is equal to 27. And we want to make these two items the same, so we can change y minus x to x minus y by adding a minus sign before it. So 10 times x minus y minus x minus y is equal to 27. And we can combine these two items into 9 times x minus y is equal to 27, and x minus y is equal to 3. So here we can find a simple relationship between x and y. And remember, the professor or the father's age is 10x plus y, and the son's age is 10y plus x. So here, we just try to find all the possible single-digit values for both x and y, and then we can find all the possible ages for the father and the son. Okay, for example, if y takes value 1, x must be equal to 4. So that means the father's age is 41 and the son's age is 14. If y takes value 2, and x must be equal to 5, so the father's age is 52 and the son's age is 25. Similarly, you can get a series of ages for both father and son, including 63 and 36, 74 and 47, 85 and 58, 96 and 69. So here I still want to demonstrate the power of the algebra method. Even this question becomes a little harder, we can still use it to solve it quite straightforward. Okay, thank you very much.